All right, so we're gonna go through some example problems where we figure out the probabilities from these two-way tables. So let's look at the first one. So here we have who owns a home. So what is the relationship between educational achievement and homeownership? A random sample of 500 US adults was selected. Each member of the sample is identified as a high school graduate or not, and as a homeowner or not. The two-way table displays the data. Suppose we choose a member of the sample at random. Find the probability that the member is a high school graduate, is a high school graduate owns a home, is a high school graduate or owns a home. All right, let's start with part A, is a high school graduate. Okay, so let's first make sure we know how to read a two-way table, because that's key. It'll be very painful to try to solve a problem if you don't know, how it works. So across the top, across the two columns, or all across this margin, you can see that here we have the high school graduates, and here we have the not high school graduates. And across this first row are the homeowners and the not homeowners, and the totals are at the end columns and end row. Okay, so let's use some notation to make this more easier to write, So we're going to find the probability of large G. So large G will represent a graduate, being a high school graduate. So what I'm going to do here is I'm going to put a large G to represent high school graduate here, and a not high school graduate will then be G complement. Because again, remember, that means that you're not a high school graduate or you're not G. And for homeowner, I'll put capital H, and for not a homeowner, I'll put H complement. That way, it's going to be a little easier to write our notation when we're solving this. Okay, so the probability of G. So it's simply just asking, out of all the 500, how many are high school graduates? So we just look at the total high school graduates, which is right here, 310. We just take 310 divided by 500, and that'll be our answer. That'll be 0.62 or 62%. Part B is a high school graduate and owns a home. Okay, so we got something else. So the probability of G will say and H, because we have G meaning that they're a high school graduate, and we have H meaning that they own a home. The probability of G and H. So we want to look at this table to see where both H and G occur. So where are the numbers that represent the people that are both a high school graduate and a homeowner? So high school graduates can only be in this column. So we don't care about these guys. And homeowners are only the top row. So then that only leaves us with the 221. Only 221 would then be both high school graduates and homeowners. We just take 221 and divide it by 500. And I think that'll give us about 0.42. Yeah, 0.442. And that's all. All right, C. Is a high school graduate now or owns a home? Okay, now we got some clever language we got to be careful of. So probability of G or H. So it doesn't have to be both of them. It could be one or the other. So we have to look at the numbers in the table that satisfy either G or H. So G satisfies, or being a graduate means, are these two. These two are the high school graduate totals. And then the homeowners are this one and this one. So it's actually these three. These three values would be either that you're a high school graduate or homeowner. So it's basically all of them except that 71. So, if you want to show your work, it's fine, but we have 221, so plus the 119, plus the 89, and divide that all over by the 500. $429 over 500, you get 0.858. All right, that's all for that. That's all we got there. Let's look at the next one. Okay, so we got a standard deck of playing cards. The jokers removed, consists of 52 cards. Okay, so just make sure, for your own sake, know what a standard deck of cards comes with. If you don't know, practice. Play play poker, or play something with your friends today or tomorrow or whenever. Make sure you know make sure you know that's 52 cards. Make sure you know the suits, the diamonds, hearts, spades, clubs, queens. Make sure you know the face cards: queen, king, jack, numbers 2, 3, 4, 5, 6, 7, all the way to 10. Make sure you're very familiar with that, because if these problems come up frequently, and you're expected to know this stuff on your AP exam. Yeah. So anyways, so let's get to the problem. So let's define events F as getting a face card and H getting a heart. Okay, so we're gonna make a two-way table that is gonna show this. Okay, so here we got to be I guess you gotta know what you're doing, but there's more than one way to set this up. So I don't think there's only one right answer. So two-way table, we had a two-way table here. So we want to write something like this. So rows and columns. So let's start like that then. A little hesitant to use pens. I don't want to mess up. So let me use a pencil here. So along the edges, we know we're gonna get the totals. And then we have to decide how we're gonna represent what the columns are and what the rows are. Now, to keep your life simple, to make your probability lives as easy as possible, try to use the fewest amount of rows as possible. So if you can only make it 2 rows and 2 columns, that's great. Because if you can make it less than that, then the problem is probably like, I don't know, something the middle school kids can do. But just as you saw here, see, we only have 2 columns and 2 rows. So even though it tells you, let's define events F gain a face card and H gain a heart, across the columns, we're gonna represent event F. Now, again, the way I like to advise you guys to think about this is, don't think about like what face card you can get, because that's gonna make your life much more complicated. You're gonna think, oh, I have to have jacks, have to row a column for queens, one for kings. And then I have to decide, oh, am I gonna put that down? How am I gonna set this up with the rows? So, and then the numbers too, what do I do with the numbers? So this is how you do it. You either can get a face card, or what's the other possibility in the universe? You're not gonna get a face card. So you either get a face card or non-face, you could say. You don't have to be specific about the card you get. You just care that it's a face card and not a face card. A face card can include jack, queen, king, but it doesn't matter. We don't care about that specific detail right in this case. We just care that it's a face card and that's not a face card. Likewise, with a heart, we don't like for the rows, don't think you have to put heart, spades, clubs, diamonds. Either you can get a heart or you don't get a heart. Well, I hope you have a heart, but I mean, in terms of playing cards. we're talking about non-heart cards. So either have a heart or non-heart card. We don't care how if it's a spade, queen, or a spade, spade, club, diamond. And let's symbolize this as face card for large F and non-face. So the complement of face card, F complement, and a heart. Remember we had H and then H complement for not a heart card. Okay, now we have to fill in the numbers. Okay, so it's always good to start with the totals because we know total is the two total cards. Okay, now, so let's think of how many total of each type we have. So again, make sure you're comfortable with your deck of cards. Now, since there's 4 suits, there's an even, or they're divided up equally. There's an even number, not even number, but there's the same number of hearts, queen, the same number of hearts, spades, clubs, and diamonds. So there's the same amount of each suit. So we just take the 50, divide by 4. That means you have 13 diamonds, 13 hearts, 13 spades, and 13 clubs. But in this, we just have the total hearts. So here we just go 13. I mean, this makes sense because if you have 3 suits that are non-hearts, 3 times 13 is 39, and that adds up to 52. So we got our totals there. Now I advise you to do the other totals, the face cards. So since we have 4 of each type of card, 4 aces, 4 twos, 4 threes, and so forth. Since there's the face cards of the jack, queen, and king, we have 4 jacks, 4 queens, and 4 kings. So we have a total of 12 face cards. And then you have 40 non-face cards because then 12 plus 40 is 52. So make sure your numbers add up. And again, start with the totals. That's what I advise. Now work on the interior. Now here, how many face cards do you have that are also hearts? How many face cards that are hearts? So since we have either a jack, queen, or king as a face card, there's only 1 jack of hearts, 1 queen of hearts, and 1 king of hearts. So that means there's only 3 of them. And then the rest, or the non-face or the non-heart face cards, we just figure out, what you add to 3 to get to 12, and so that'll be 9. And the rest, you already, adds up again. You just do how many you have to add to 3 to get to 13. So you have a 10 here and a 30 here. You have 10 non-face heart cards and 30 non-face non-heart cards. That's our table. That's part A. So that's the hard part. The rest should be easy as long as it's your table correctly. Now, let's look at the probability of a face and a heart. So part B, probability of face and hearts. So look for the values that represent or satisfy both being a face and a heart card. And since this is our face column and this is our heart row, we're just looking at this. We're just looking at this number right here. It's just going to be 3. So there's probability of being a face and a heart card is just 3 out of the total number of cards, so 3 out of 52. It doesn't come out to a very nice number, so you could probably leave it like that. If you wanted to round, it'd be about 0.058. And part C, find the probability of a face or heart card. Okay, so remember, it doesn't have to be both, just one or the other, or both, it could be both. So let's look at the face cards. So these 2 numbers represent the face cards. So we got the 3, we got the 9, and then which one of the heart cards would be the 3, the 3 and the 10. So we just have the 3, the 9, and the 10 would either be a face card or a heart card. So then the probability of a face or heart card would just be 3 plus 9 plus 10 out of 52. Or 22 out of 52. And again, that doesn't really come out to a nice number, but if you want to round it, it'd be about 0.423. All right, and that's all there is to it.